Okay, so today we're going to talk about Bayes' theorem. Bayes' theorem. So we're on page 163. Bayes' theorem. This is fairly complicated. As a matter of fact, I'm surprised that this is in the book because I don't teach this in AP Stats. Did we skip this in AP Stats? It's in here, and Shemekina tells me to teach it, so I'm going to teach it. Okay, so let's go. Bayes' theorem. Let's go ahead and the bottom of page 163, last paragraph. Let's consider. Sam would read this for us.
Let's consider a study showing that physicians often give very misleading information when they experience confusion of the inverse. Intended to confuse probability of cancer and positive test result with negatively positive test result of cancer. About 95% of physicians estimated probability of cancer and positive test result to be about 10 times too high, with the result that patients were given diagnoses that were very misleading. Patients were unnecessarily distressed by the incorrect information. Let us take a closer look at this example, and let's hope that we can give physicians information in a better format that is easy to understand.
All right, thanks. So, yeah. So the physicians, the doctors, these people who are in charge of your body and make these big decisions tend to misunderstand this, okay? So let's go ahead. We're going to go to the example number 4 on page 164, and we'll look it through. So, doctors are generally supposed to be pretty smart, but just like normal people, right? You would think that the percentage of smokers in doctors will be much lower than regular people, but they're not. Okay, doctors smoke just as much as other people do. The obesity rate in doctors you would think would be much lower. They're not. They're just the same as normal people. Okay, so they're human beings. Okay, so let's go to example number 4. Assume cancer has, so pay close attention. Assume cancer has a 1% prevalence rate, meaning that 1% of the population has cancer. Denoting the event of having cancer by C, we have that the probability of C is equal to 0.01 for a subject randomly selected from the population. This result is included with the following performance characteristics of the test for cancer. Okay. It says, the first bullet, we just talked about that. There's 1% prevalence rate. The second bullet, the false positive rate is 10%. False positive. What does that mean?
This is that you have cancer, but in reality you don't actually have it.
Correct. So if you you have a positive test, okay, you actually do not have cancer, is 10%. Okay? So that is, okay, we talked about that. So the third one, the true positive rate is 80%. That means that the probability that you have positive test result given that the cancer is present is 0.8. Okay, so what they want us to find is the probability of, given that we have a positive test result, what is the probability that I actually do have cancer? Because that's what you really want to know, right? Because you were talking to a patient and we did a test, and guess what? It's positive, okay? So as a patient, the first question I'm going to ask the doctor is it true? Right? Could it be a false positive? Right? And that's what we would ask, so the doctor would need to know this stuff. Right? Okay. And so we'll discuss what we find in the result. Okay? So the best way to do this is actually just go ahead and make up a table. Okay, so we're gonna make up a table. We're gonna say we have 1,000. We did 1,000 tests. Okay, and then we're gonna have positive tests and we're gonna have negative tests, right? And then we're gonna have whether we actually have cancer or we do not. Okay? So everyone understand what's going on? So this is the test result. This is the true whether I have cancer or not. Okay? So we're gonna say that we had 1,000 people. We tested 1,000 people. Okay? So if I tested 1,000 people, okay, how many of these are going to give me a positive test out of 1,000? 10, isn't it? 10, right? Well, okay, well, how many people have cancer? How many people have cancer? 10 have cancer, right? Right? So 10 are going to have cancer. Right? Which means that how many are not going to have cancer? 990, right? Because I am doing 1,000 people. Right? Out of the 10, how many actually have cancer?
8.
How many have, so positive, right? So testing positive is going to be 8, and the leftover would be 2. Correct? Okay. What about the no? What about here? What is this? How many are going to test? What does it say? 99, which is 10% of that, right? 10, because what was the thing they told us that, right? The false positive rate is 10%. Right? And the rest here would be, so I'd have to subtract that, so it'd be 891. Okay, you see that how we just kind of made this up, right? We made this up. What was the question? What we were trying to find? We're trying to find, given you have a positive test result, so given you have a positive test result, so how many of these have positive test result? How many positive tests do I have? 107, right? I'm going to add these two together to get 107, right? And how many of these are actually correct that I have cancer? 8. So that's your answer. Right? That's what you're asking. That's what they want to know, right? Okay. So if you look at page 165, they do a bunch of whatever the stuff, but they come up with this, which is 0.07 something, 748. So 7.48, well, 7.5%, right? 7.5%. Okay. All right. So let's go ahead and look at the study results here. Here's a truly fascinating fact. 100 physicians were given the information in example number 4. 95 of them estimated it to be 0.7, 70% instead of the 7.5%. Okay? That's where, remember we talked about on the earlier page when Sam was reading it, it said there was 10 times, they estimated to be 10 times more. Okay? So this is what they're talking about. Okay? Physicians are extremely intelligent, but yes.
But can I take my pre-calc test during stats? Mr. Reis needs to know because Tanvir's not here, so he wants me to go to a radio spot with Abby. So during 4th period.
What? So during 4th period.
No, during 3rd period, can I take
During
the 4th period?
third, so you're gonna miss this lecture.
No. Wait. No. Yes, I'll miss that lecture to take the quiz during that one.
Instead of, would you have any other appears here that you could take the test?
Well, I guess I could come later if you want me to hit the lecture.
Oh, yeah, I'd rather you
Okay.
get the lecture.
Well,
Okay?
alright.
Okay. Okay, so, we understand what's going on here? Okay, the 7.5% versus what most of the physicians think as being 70%, okay? All right, so we were talking about, so physicians are extremely intelligent, but here they likely suffered from confusion of the inverse. The given rate of 80% for positive test results among those who are true positives implies that P positive, given you have cancer, is 80%, but this is very different from the probability of you having cancer given that you've gotten a positive test. Okay? That's a difference there. Okay? All right. So it continues to say the importance and usefulness of Bayes' theorem is that it can be used with sequential events, okay, whereby new additional information is obtained for a subsequent event, and that new information is used to revise the probability of the initial event. So in this context, they have prior probability and posterior probability. Okay? Don't worry about too much about that. Have you guys ever read or heard of the whole door A, door B, door C thing?
Oh, yeah.
Right? This is exactly that. Okay? So now if you read that, maybe it makes a little more sense. Okay? All right? So that's that, and that is Bayes' theorem. Okay? If you do not understand that, do not fret too much. Okay, like I said, this is not the easiest thing in the world to understand. Okay? So I'm going to go ahead and give you homework associated with this.